Hey everyone, so today we're going to do our last lesson of radicals, and I'm not going to be using the whiteboard, nor will you see my face, but I'm here and you can hear me hopefully. I'm going to do the whole thing with the graphing calculator. Now if we had been together in class, this would have been a lesson that we would have done by hand without a calculator, but since we're in this setting, it would be best to just use the calculator and still get the point across. So hopefully this will be really quick and easy, but still helpful in learning. Okay, so I want you to see what the graphs for some radical functions look like, and then we're going to talk about transformations of those graphs as we have done all year. So the first one we're going to take a look at is the square root of x. So I'm on the y equals screen right now, so that would be the top row first button. So when you press that, you get the y equals screen. We've used this before. Okay, so you're going to go to square root. So square root is about halfway down with the square button, but you have to press second. So I'm going to press second, square root symbol, and just put an x inside, and then press graph. Now the computer screen goes much faster than the calculator, so I'll give you a second to make sure you get the same graph. Okay, so this is the typical square root graph. So I want you to go ahead and copy that over to your note sheet where the graph is given to you. And the way you would do that is to go to the table. So if you press second graph, that brings up the table. Now my particular table started at 0, but I want you to back up using the up arrow and look at what happens when you have a negative number. Like all of the negative numbers say error. Now the reason why that's happening is if you take the square root of a negative number, it's not real. Remember we discussed imaginary numbers earlier this year? That's what's going on here, is any negative number would be an imaginary result if you took the square root of it. So nothing's wrong with our graph, it just means that those are not real solutions, they are imaginary. So you would not plot those on your graph. So now I'm going to just arrow down past all those back to where I was. So you want to start right here and like plot 0, 0, plot 1, 1. And there are some decimals, but you could skip over those because later there's 4, 2. And a little later there's 9, 3, and so on. So plot the whole numbers at least. So your graph would start at 0, 0. And it would continue to the right, like even past 9, 3, there would be more values. They're just too high to plot on our graph. So when you finish, you want it to look like the graph. And just make sure that over here you have an arrow on the end to show that it would continue. Okay, so that's the typical square root graph, which we call the parent function. Okay, we're also going to look at the cube root function. So this is a little different. So go to y equals, you can erase that one. And we're going to put in the cube root of x. So you go under math, cube root is the fourth one, put an x inside, and graph. So this is the cube root of x. And yours will probably go slower than that, so I'll give you a sec. Okay, so this would be the parent function for the cube root. Okay, so I want you to copy this over to your note sheet, and you can do that by going to the table again. So that's second graph, and you can use the up arrow. Now this time you'll see that negative numbers do not give an error. Negative numbers actually have values. So the reason for that is that you can take the cube root of a negative number. So like for instance, the cube root of -8 is -2, so that's the point that's highlighted now. So plot that one, -8, -2. Come down a little further. I'm going to just plot the whole number. So how about this one? -1, -1, 0, 0, 1, 1, and then a little bit later, 8, 2. So plot those points, the ones that are whole numbers. And remember, when you finish, it should be that. Now keep in mind on the left side, you should have an arrow to show that it would continue further over here. And on the right side, there would be an arrow. So always include the arrows like you normally do. So that is the parent function for cube root. So then all of the transformation rules that we studied throughout this year apply to these graphs as well. So I just want you to see a few examples of how they compare. So let's take a look at number 1 at the bottom. Okay, so it wants you to graph, let me erase this, the square root of x. So that would be the parent function. So second square brings the square root, put x on the inside. And we want to look at the other one at the same time. So that would be your first equation. Use the down arrow to get to line 2. And then the next one is 3, and then square root. Then there's x plus 5 inside of the square root. And I'm pressing the right arrow to get out of the square root. Okay, so that's how it should look. 3 times the square root of x plus 5. Okay, so go ahead and press graph. Now the blue one is the parent function that we looked at originally. The red one would be the new graph. So I want you to note the difference between the two. I do want you to graph this on your note sheet. So take a moment to go to the table and plot some points. So for the blue graph, you would use x values here with y1. And then for the red graph, you would use like x values here with y2. So just plot anything that was whole numbers. So you'll see that for the blue graph, you would have to start at 0, 0, and then use like 1, 1, and 4, 2, and then later it was 9, 3. But for the red graph, if you'll notice, there are some negative values. So go back for the red one. There's negative 4, 3, negative 5, 0, and then you start seeing the errors. So begin the second graph at negative 5, 0, and then negative 4, 3, and then negative 1, 6, and work your way down from there. Let's see if there's anything else. Yeah, 4, 9 would be another one on the second graph. Okay, so when you finish, you will have these two graphs together. Now the directions say to describe the transformation from f to g. So the rules that we have studied earlier in the year will tell us what happened. Okay, so if you go back to the two equations, so for me, I'm just going to go back to the graph screen. The square root of x is the parent. So in the new graph, there's a 3 on the outside. So that 3 is called a vertical stretch by 3. So that means each y value was multiplied by 3, which made it vertically stretch. So write down a vertical stretch by 3. The other thing is the positive 5 that is inside of the radical. That would be a shift to the left 5. And if you look at the graph, that should make sense because the original graph started at 0, 0, but over here it's been shifted to the left 5. So make sure you write down 2 transformations for this one. It's a vertical stretch by 3 and a shift to the left 5. All right, so for number 2, it's the same original graph. That's called the parent function. So I'm going to leave that alone. Down to the next one, I'm going to clear that one. So this one has a negative sign. That's not subtraction, it's a negative sign. Then the square root button. Oops, I pressed the wrong thing. Clear it out. Okay, so a negative sign first, then the square root. Okay, note that x is on the inside, but then there's a subtraction by 3 on the outside. So for me, I need to get out of the radical, so I'm pressing the right arrow and then subtracting 3. So be careful with this one. This one is a negative symbol, and this one over here is a subtraction symbol. So those are 2 different symbols. Now, if your calculator is different than mine and you don't have the right arrow thing, what you will probably have to do is put the x in parentheses, close off the parentheses before you put -3. But the graph that you should be getting would be like, let me see. Sometimes my cursor disappears. There it is. Okay, so graph this, and here are the 2 things that you should see. So just like before, I'd like you to go to the table and plot some points. And this time, both of them have errors for negative values, so you'd want to start with, like, on the blue graph, 0, 0, and then 1, 1, and 4, 2. On the red graph, you'd have 0, -3, 1, -4, 4, -5, and so on. Okay, so get those points plotted. Probably need to stop the video and do that. Pause it and go back to this graph. Okay, so what transformations have happened? So we've studied these rules earlier this year. So the negative sign that's in front of the radical on the second equation, that negative, that is called a reflection across the x-axis. And then the -3 that is over here on the outside of the square root, that would be a shift down by 3. Okay, so if you go back to the graph, the reflection across the x-axis made the second graph flip over, and then it also shifted down 3. So you can kind of see it visually here. Okay, so those two were square root graphs, so we're going to look now at cube roots. So I'm going to erase both of these now. So we want to look at the original parent function for cube root. So go to math, and 4 is cube root, and put an x inside. That will be the original parent function. So for the new one, we have 1/2. Let's put in 1 divided by 2. Find cube root again under math, number 4. And then we have x minus 4 inside of the radical symbol. I'm pressing the right arrow to get out. Okay, so those are your two equations. And I'm going to press graph to see how they look. So we have the original blue one and then the red one. And I want you to go to the table and plot points. And again, you can skip over the decimals. I would just plot the whole numbers. So if you go back, you'll find on the blue graph there's -8, -2. Further down there's -1, -1, 0, 0, 1, 1. There's also 8, 2. If you go further, and let's see, on the red graph, so I see something here, -4, -1. You could plot that. And then we can look down and see if there's more things. Looking for red values, that would be good. 4, 0. There's 12, 1. So there's a few things you can plot there. There aren't decimals. Okay, so back to the graph. That should be how it looks when you're finished. And you want to put arrows on the ends of each one. Okay, so what transformations have actually happened here? Let's go back to the two equations. So the parent function is just the cube root of x, so that is what you want to compare to. So look at the new graph. So the half at the beginning, that is called a vertical shrink. So that made all of the y values smaller than what they were before. So the half is the vertical shrink. And then the -4 that is inside of the cube root, that would be a shift to the right 4. So one more time, this is called a vertical shrink by 1/2 and a shift to the right 4. Okay, so one more and we'll be finished. I'm going to keep that first one the same, so just arrow down. And I'm going to erase the second one. Okay, so this one has a -4. That's a subtraction symbol, it is a negative symbol, not subtraction, was I meant to say. Okay, so -4, cube root symbol under math, number 4, and inside of it is just the x. So I'm going to put the x in there, but use the right arrow to get out of the radical, and then put +4. So if you have a different style calculator than I do, you may need to put the x in parentheses and then close off the parentheses before you put the +4. Okay, so this would be the graph that should appear on your screen. Like before, I would like you to go to the table, so second table, and plot points. And again, you can skip over anything that's a decimal and find just whole number values. Okay, so transformations on this one. So look at that graph and look at this equation. So the cube root is the parent function. So we want to compare the second equation to that. So this one has several things going on. So first of all, the negative that is at the very beginning, that is a reflection across the x-axis. The 4, think of that as a positive 4. That would be a vertical stretch by 4. And then the other 4 at the end, the plus 4, that would make the graph shift up by 4. Okay, so 3 things you should write down for that one are reflection across the x-axis, a vertical stretch by 4, and then also a shift up by 4. Okay, so that is it for the day, and we're done with radicals, so next time we will start something different. I'll talk to you later. Oh, before I sign off, interim reports are due Wednesday at noon. So since this is such an easy assignment, I'm going to have it due Wednesday morning so that I could get the grade in before interims come out. So try to get this done ASAP. I'll talk to you next time. Miss you guys. Bye-bye.